what will be the sum of mole fraction of all the components in the solution? It will be equal to 1. So if the volume is present in liters, then you need not use this 1000. And if the volume is given in milliliters, what you have to do? You have to multiply it by 1000, right? So how can I write the equation like we have written in molarity? Yes, it will be WB by MB, that is number of moles of the solute, right? Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So today we are back with session 2 of the chapter Solutions. So in last class, we discussed about the different types of solutions. Yes, solid solutions, liquid solutions and gaseous solutions in detail. And then we studied about the concentration of solution, in which we studied about the various concentration terms which are used to express the concentration of the solutions, right? So in last session, we discussed about mass percentage, volume percentage and mass by volume percentage. So in today's session, we will be discussing the rest of the concentration terms, that is mole fraction, molarity and molality. And then we will be moving on to the next topic, that is solubility, right? So beginning with the mole fraction, the next concentration term, that is mole fraction. Yes, so what is mole fraction? It is the ratio of number of moles of a particular component to the total number of moles of all the components in the solution, right? It is the ratio of number of moles of which component you want to measure, the mole fraction of which component you have to measure, the number of moles of that component divided by the total number of moles of all the components present in that solution. So you can see in the equation that is given here, mole fraction is equal to number of moles of the component by total number of moles of all the components. And mole fraction is represented by the symbol chi. It is not X, it is chi. Okay, it is represented by the symbol chi. So in a binary mixture, if we are saying, if you are considering a solution having only two components, that is binary mixture, right? And if NB is the number of moles of solute and Na is the number of moles of solvent, then what will be the mole fraction of solute? Yes, it will be number of moles of solute divided by total number of moles of all the components, right? So which are the components here? A and B, right? So it will be NB by Na plus NB. Yes, so chi B will be equal to NB by Na plus NB. Right, and in the same way, if you have to find the mole fraction of the solvent in the solution, it will be, yes, Na, that is number of moles of solvent divided by the total number of moles, that is Na plus Nb. I hope it is clear. Now, if there are more than two components, let's say for a solution that contains a large number of components, we are considering, yes, A, B, C, D, E till I components are there. Okay, if that, in that case, if I want to find out the mole fraction of just D, how do I find? The same equation, right? Yes, the number of moles of D divided by all the number of moles. Yes, the number of moles of all the components present. Yes, I hope it is understood what is mole fraction. Yes, so you understood how to calculate the number of moles of different components in a solution. So, what will be the sum of mole fraction of all the components in the solution? It will be equal to 1, right? Yes, if there are two components, yes, the mole fraction of A plus mole fraction of B will be equal to 1, right? Yes, so as you can see, NB by Na plus NB plus Na by Na plus NB will be equal to 1, right? Even this is very important. Clear? Now let's do a numerical based on this, right? So calculate the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. Okay, so mass percentage is given here, that is 20%. Yes, so what do you have to calculate? You have to calculate the mole fraction of ethylene glycol in solution, right? So as given, mass percentage is given. So 20% of ethylene glycol by mass means 20 gram of ethylene glycol in 80 gram of water, right? We studied this. Yes. So, from that, how to calculate the mole fraction? We know that we have to find the number of moles of, yes, ethylene glycol, as well as we need to find the number of moles of water as well, right? Because it is number of moles of the component divided by total number of moles. We require the number of moles of both, right? So I am trying to find the number of moles of ethylene glycol, right? As it is a solute, I am writing it as NB. Okay, it is equal to, we know that 20% of ethylene glycol by mass means, yes, we know the mass. Yes, how to find number of moles? Yes, given mass by molar mass, right? So 20 divided by, what is the molar mass of ethylene glycol? How do you calculate it? It is the sum of atomic mass of each of the atoms present in it, right? So it will be 12 into 2 plus 6 plus 2 into 16, right? That will give 62. Right? So what is the number of moles of ethylene glycol? It is 0.32. Right? Yes. Now we have to calculate the number of moles of water as well. So that is the solvent. So I write it as Na. Okay. Now what is the mass of, yes, how do you calculate number of moles? Mass by molar mass, right? So what is the mass here? Yes, it is 20% ethylene glycol by mass means the rest is water, right? So it will be 80, right? 80 plus 20 gives you 100, right? Clear. So divided by, yes, what is the molar mass of water? It is 18, right? So that gives you 4.4 moles, right? So here it is 0.32 moles and here it is 4.4 moles. Yes. Now we calculated the number of moles. How to calculate the mole fraction of ethylene glycol? Yes, the mole fraction of ethylene glycol will be number of moles of ethylene glycol divided by the total number of moles. Right? So that will be equal to, what is NB? 0.32 divided by 0.32 plus 4.4. Yes, which will give you the answer 0.068. Yes, so that will be the mole fraction of ethylene glycol in the solution. So I hope it is clear. Now moving on to the next concentration term, that is molarity, which is represented by capital M. Okay, so what is molarity? It is the number of moles of solute dissolved in 1 liter of solution. It is the number of moles of solute dissolved in 1 liter of the solution, which is called as molarity. Clear? Yes. So how do you write it in equation? Molarity is equal to number of moles of solute divided by volume of the solution in liters. Right. So how do you calculate number of moles? It is mass by molar mass, right? So you can write it in this form also, that is mass. WB represents the mass of the solute divided by molar mass, right? That is molar mass of the solute. So this part you can see, that is basically the number of moles. Yes, so you can write this equation in this form as well. Yes, then divided by volume of the solution, that is V here. Right? So if the volume is present in liters, then you need not use this 1000. And if the volume is given in milliliters, volume is present in milliliters, you have to divide it by 1000. So that if it is divided by 1000, that comes to the numerator, right? So that is why this 1000 is here. So altogether, you can write molarity in this form also, where WB is the mass of the solute. Yes, MB is the molar mass of the solute and V is the volume of solution. So this 1000 is required only if the volume is present in milliliters. Clear? Now, one important thing about molarity is that molarity is temperature dependent. We know that molarity is number of moles of solute present in 1 liter of solution, right? So, yes, we are talking about the volume, right? We know that volume is a temperature dependent factor, right? It's temperature dependent. Volume is temperature dependent. So what you have to remember is, yes, molarity also changes with temperature. Yes, that's clear. Now let's do a question based on this. Now calculate the molarity of a solution containing 5 gram of sodium hydroxide in 450 ml of solution, right? So you have to calculate the molarity. What's the first step? We know that molarity is equal to number of moles of solute in 1 liter of solution. So how can you calculate the molarity? Yes, molarity will be equal to, yes, we studied this equation, right? We can use it here. Yes, so it is WB by MB. Yes, that is number of moles in 1 liter of solution, right? So into V, and in the numerator I have to use 1000 because it is given 450 ml, right? In ml it is. So into 1000. Clear? Yes. So what is the given mass? It is 5 gram of sodium hydroxide, right? So 5 into 1000 divided by, what is the molar mass of sodium hydroxide? It is 40, right? And it is present in how much volume of the solution? 450 ml of solution, right? So 40 into 450 ml, right? So that will be equal to 0.27 molar solution, right? Yes, so the molarity we calculated. Yes, I hope it is clear. Now moving on to the next concentration term, that is molality. Yes, it is different, molarity and molality. Now molality is represented by the symbol small letter m, right? Molarity is capital M and molality is small m. Now what is the difference? Yes, molality is the number of moles of solute, yes, dissolved in 1 kg of the solvent. Okay, not solution. It is the number of moles of solute dissolved in 1 kilogram of solvent. Clear? Yes. So how do I write the equation? Molality will be equal to number of moles of solute divided by the mass of the solvent in kilogram. It's not volume here. It is mass of the solvent in kilogram. So how can I write the equation like we have written in molarity? Yes, it will be WB by MB. That is number of moles of the solute, right? WB by MB. Now what else is there? Mass of the solvent in kg. That is WA. Yes, if it is given in grams, we have to multiply it by 1000. Yes, so where WB is the mass of solute, yes, MB is the molar mass of solute and WA is the mass of the solvent. So you have to remember A is for solvent and B is for solute. Clear? Now in the case of molality, what it is? Yes, we discussed molarity, it is temperature dependent. But molality is not temperature dependent. Why it is that? Yes, because the mass is independent of temperature. Yes, volume keeps changing with temperature. But does mass change with temperature? No, mass is a constant value, right? It doesn't change with temperature. So that means, yes, molality is also temperature independent. Clear? So while we are comparing the two concentration terms, that is molarity and molality. Molality is the more preferred one because it doesn't change with temperature. I hope it is clear. Yes. Now let's move on with a question for molality as well. Yes, calculate the molarity of 2.5 gram of ethanoic acid in 75 gram of benzene. So how do you calculate molality? Yes, it's represented by small m, right? Molality is equal to, yes, number of moles of solute. Yes, present in 1 kilogram of the solvent, right? So it is MB into WA into 1000. Right, again it is given in grams, not kilograms. So we have to use this 1000. Yes. So, yes, calculate the molality of 2.5 gram of ethanoic acid. Mass is given here. So 2.5 into 1000 divided by, what is the molar mass of ethanoic acid? How do you calculate it? Same way, the atomic mass of each of the atoms present in here, you have to add it, which is equal to 60. And what is the mass of solvent present there? It is 75 gram of benzene, right? So the mass of solvent is given there. So into 75. Yes, so this 1000 is used to convert into liters, right? So what is the final answer then? 0.546 molal. So this small m that I have written here, you have to spell it as 0.546 molal. And if it is capital M, it is molar solution. Clear? So yes, we calculated the molality. I hope it is clear. Yes. So I hope the concentration terms that we have discussed till now is clear for you. Yes. So now we are moving on to the next important concept, that is solubility. Yes. So what exactly is solubility? Yes. Solubility of a substance is the maximum amount of solute that can be dissolved in a specified amount of solvent. So it is the amount of solute that can be dissolved in a given amount of solvent. How much of the solute can be dissolved in a given amount of solvent? That is called as solubility, right? Now there are certain factors on which the solubility depends. That is nature of solute, nature of solvent, temperature and pressure. On these factors, the solubility depends. Okay, so first let's discuss about the first two factors, that is nature of solute and nature of solvent. Yes, we know that only certain substances get dissolved in certain substances, right? So that means we know that, as you can see here, does oil get dissolved in water? No, right? But if in the same case I am taking sugar or salt, what happens? It gets dissolved in the water, right? So in the case of solubility, right, considering the nature of solute and solvent, one important thing that you have to remember is like dissolves like. Okay, like dissolves like. That means, yes, the polar substances only dissolves in polar substances. Yes, if the solute is polar, then the solvent must also be polar, then only the solute will get dissolved. Yes, and the non-polar solute get dissolved in only non-polar solvent. So that is what I have written here, like dissolves like. Okay, so in this case, let's take this case, if sodium chloride, that is salt, if I am trying to dissolve it in water, it dissolves, right? Because sodium chloride as well as water, both of them are polar substances, right? Now, the same sodium chloride, if I am trying to dissolve it in benzene, okay, if I am trying to dissolve it in benzene, it doesn't dissolve. Yes, because yes, benzene is a non-polar substance, but sodium chloride is a polar substance. So what happens? Yes, they do not dissolve. Clear? Yes, so that is about the nature of solute and nature of solvent, that is only like dissolves like. Yes, so I hope it is clear about solubility. So now in this chapter, we will be discussing about solubility of a solid in a liquid and the solubility of gas in liquid. These two we will be discussing in this chapter. So solubility of solid in liquid means, yes, the solute is solid and the solvent is liquid. Now solubility of gas in liquid means, yes, the solute is gas and the solvent is liquid. Yes, so we are beginning with the first one, that is solubility of solid in a liquid. So what happens? Yes, when a solute, that is a solid solute, is dissolved in a liquid. Clear? So for that we have to understand few processes that happens there when, yes, the solid is being dissolved in a liquid. Right. So first thing we understood that only like dissolves like. Right. Now moving on to the first process that happens, that is dissolution. Now what is dissolution? Yes, the solute get dissolved and its concentration increases in the solution. That means, yes, let's take the same example. If I am dissolving sugar into water, yes, I take 1 spoon of sugar, I add sugar into water and I mix it. Yes, what happens? The sugar get dissolved in the solution and the concentration of the solution increases. Right. So that process is called as dissolution. That is, solute get dissolved in the solution and its concentration increases in the solution. We know that what is concentration? It is the amount of solute present in the solution, right? So when I am adding solute, that means the concentration of the solution also increases, right? So that process is called as dissolution. Now the next one is crystallization. Now what I am trying to do is, I keep on adding sugar into it. Now what happens? Yes, after a while I add excess of sugar to it. Yes, the solute particles collide with the solid solute particles and get separated out. Right. What happens now? It stops dissolving in the solution, in the water. Right. It stops dissolving and what happens? Yes, it crystallizes. Yes, what happens? You will be able to see that the sugar is not getting dissolved again. It is colliding with each other and it is separating out as crystals. So that process is called as crystallization. Yes, so in the beginning, yes, the solute gets dissolved. That process is called as dissolution, which increases the concentration of the solution. But later what happens? Yes, crystallization process happens. Because, yes, now it can't be more soluble in the solution. So now when these two processes, that is dissolution and crystallization, are happening equal rate, yes, what happens? It attains equilibrium. Right? It attains dynamic equilibrium, we can say. Right? So that is dissolution and crystallization process happens with equal rate. What happens? Yes, it attains equilibrium. So I hope dissolution and crystallization is clear for you. Now we have to learn what is saturated and unsaturated solution. So yes, what does the saturated means? So we often say that yes, you studied a lot for the day. Yes, you studied for 6 to 7 hours continuously. Now you are saturated, right? Now no more you will be able to study. I am done for today. Yes, so that thing, that is saturated, right? You say that you are saturated, right? So in the same way, what is saturated? Solution. A solution in which no more solute can be dissolved at the same temperature and pressure. Okay, like you say that I am saturated, I can't study anymore today. The same way, the solution also can't accommodate any solute into that. Yes, that is a solution in which no more solute can be dissolved. Yes, at what is this important part? At same temperature and pressure. So, at a particular temperature, yes, no more solute can be dissolved. But if we change the temperature and pressure, yes, more amount of solute can be dissolved. Okay, that is important. So, this part is very important. So, that is saturated solution is the solution in which no more solute can be dissolved at that particular temperature and pressure. So, if we change the temperature and pressure, yes, more amount of solute can be dissolved. Now, what is unsaturated solution then? A solution in which more solute can be dissolved at the same temperature and pressure. So, this unsaturated solution means, yes, some more amount of solute it can accommodate in the solution. Yes, some more amount of solute can be dissolved in the solution. So, I hope saturated and unsaturated solution is clear for you. So, now we are going to see the effect of temperature of solubility of solid in a liquid. Yes, when we are trying to dissolve a solid in a liquid, how does the change in temperature affect the solubility? Right? So, the solubility of solid in a liquid is significantly affected by temperature. So, how does it affect with temperature? We are going to see. So, according to Le-Chatelier's principle, which you have studied in class 11 itself, in a nearly saturated solution, yes, if the dissolution process, we know what is dissolution, right? The dissolution process, if it is endothermic, that is delta H is greater than 0. What is endothermic process? Yes, when the energy is being absorbed, right? If the energy is absorbed by the system, we say that it is endothermic. Clear? So, if the dissolution process, if it is endothermic, yes, the solubility increases with temperature. Yes, the system is absorbing energy. So, what happens? Yes, the solubility also increases with temperature. Now, if it is exothermic process, that is delta H is less than 0. Exothermic means while the dissolution process is happening, yes, the solution is giving away energy. That is exothermic, right? The system provides energy. Right, from the system the energy is being released, right? So that is exothermic process. So what do you think? Yes, the solubility decreases with increase in temperature. Yes, so if it is endothermic process, yes, if it is endothermic process, the solubility, what happens to the solubility? It increases with temperature. It is directly proportional. And if it is an exothermic process, that is, if the dissolution process is exothermic, then solubility will decrease with increase in temperature. That is, it becomes inversely proportional. So, you are clear with the effect of temperature on solubility of a solid in a liquid. So, now what about effect of pressure? Does the change in pressure cause a change in solubility of the solid in liquid? No. Okay. So, effect of pressure doesn't have a much major effect on the solubility of solid in liquid. As you can see, the pressure does not have a crucial effect on solubility of solid in liquid because, yes, what? They remain unaffected to pressure due to the high incompressibility of solids in liquids. So, we know that solids are incompressible, right? They are highly incompressible. We know that gases are highly compressible, but solids we can't compress it, right? So, we can't compress it, or if the solids are highly incompressible, that means, yes, will there be any effect on pressure? Pressure is actually a force. What is pressure? Pressure is force applied in a unit area, right? Yes, so if I am not able to apply a force, that is, if it is not compressible, then will it have an effect on the solubility? Will pressure show an effect on the solubility? No, right? So, what you have to remember, in the case of solubility of solid in liquids, yes, the effect of temperature is important, but the effect of pressure, it has no effect of pressure. If we change the pressure also, it doesn't create much of a difference in the solubility of solid in liquid. So I hope the first part, that is solubility of solid in liquid, is clear for you. Right? So in the next session, we will be discussing about the next one, that is solubility of gas in liquid, where you will be studying Henry's law, and then the application of Henry's law will be also discussed, and then we will move on to the next topic, that is vapor pressure of liquid solutions. So I hope what and all we have discussed in this session is clear for you. So that's all for today. Thank you.